Hello viewers, so welcome to my channel. I am Hasham. So last video I have explained you the complete theory regarding Poisson distribution. It's a probability distribution which is applied in discrete data where the values of R will be in whole numbers, integers. And this Poisson distribution is a limiting factor of binomial distribution. In some certain circumstances, the binomial distribution will not be suitable. That means the calculations will be more. It's a tedious, time consuming. So in those situations, we apply this Poisson distribution. So simply Poisson distribution will be applied when the value of P, probability of success, is very small and the N, the number of items, are very large. When N is large and P is very small, in that circumstance, Poisson distribution is very much suitable. There are many cases where the rare events will happen. That means the probability of success will be very, very less. In those circumstances, Poisson distribution will be applied. So hope my regular viewers have already watched that video. If you have not watched, I suggest you go to the playlist of my channel. Select the subject statistics for management. Select the video of Poisson distribution theory. Be perfect. Then you can understand the problems. Now I'm going to start the problems on Poisson distribution. First 4 problems I'm going to explain you in this video. So watch the video till the end to get the complete command. Now, before starting the first problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. If you don't have the problems, you cannot understand my lecture. So always follow my instructions, keep ready the problems, and also keep a notebook, calculator, pen ready at the time of watching the video. Now take the screenshot of the points of the first 4 problems, then I'll explain every point in detail. Now, see the first problem. Suppose on an average, one house in 1000 in a certain district has a fire during the year. That means out of 1000 houses in a locality, there's a chance of one house catching the fire. So out of 1000, only one house is the chance of catching the fire. If there are 2000 houses in that district, what is the probability that exactly 5 houses will have a fire during the year? So in that particular locality, total number of houses are 2000. What is the probability that in those 2000 houses, 5 houses will catch the fire? What is the probability that a house will catch the fire? One house out of 1000. So we can write the data as follows. P is equal to probability of fire at a house. Total out of 1000 houses, 1 houses there is a possibility of fire. So 1 by 1000, this is the value of P. Now N, total number of houses are given 2000. So you can see N value is very large, 2000. We never came across N is equal to 2000 in binomial distribution. Here N is very large. P is very small, 1 divided by 1000. So M is equal to NP. M is the main parameter in Poisson distribution. So what is M? N into P. Multiply N into P. So 2000 into 1 by 1000. So these 3 zeros will get cancelled. So M is equal to 2. The main parameter M is equal to 2. Now it is not given in the problem that we have to apply Poisson distribution. Since the N is very large and P is very small, so in this problem it is very much suitable to apply Poisson distribution. So we apply Poisson distribution law. According to Poisson, the function, probability function is P of R is equal to e to the power of minus m into m to the power of R divided by R factorial. So this is the formula for probability of R successes. Right? Now P of R is equal to e to the power of minus m. How much is m value? 2. So e to the power of minus 2. into 2 to the power of r, because e to the power of minus m, m to the power of r. So in place of m, I am writing 2. So e to the power of minus 2 into 2 to the power of r divided by r factorial. Now, ultimately the question is, what is the probability that 5 houses will catch the fire? In that locality of 2000 houses, what is the probability 5 houses will catch the fire? That is, r is equal to 5. So in place of r, I am writing 5. So e to the power of minus 2, 2 to the power of 5 divided by 5 factorial. We have substituted. Now we need the value of e to the power of minus 2. Sometimes in examination it will be given in the problem, e to the power of minus m value. And if it is not given, then you have to refer the table, Poisson distribution table. This is the Poisson distribution table. I will provide this table as a PDF in the link under my description. Take a copy, or in any textbook you can find the value of Poisson distribution. Always keep it at your hand, right? So how to locate if the m value is fractional value? See the first big table. Below that small table is also given. If the m value is in whole number, if this m value is in whole number, refer the small table below. If the m value is in fraction, refer the first big table, right? Now first of all, here we got m is equal to 2, whole value, whole number. So below table, m is equal to 1, 2, 3, 4, 5, 6 up to 10 values. And below it, e to the power of minus m. Here for every value of m, we are given the e to the power of minus m value. We want e to the power of minus 2. So in the table, you can see carefully, e to the power of minus 2 is equal to 0.13534. 0.13534. This is the value you can refer from the table. So 0.13534. This is the value of e to the power of minus 2. Now substitute p of 5 is equal to e to the power of minus 2, 0.13534 into 2 to the power of 5. 2 is multiplied 5 times. 2 into 2 into 2 into 2 into 2. You will get 32. So 2 power 5 is 32. 5 factorial means 5 into 4 into 3 into 2 into 1. So if you multiply all denominator, you will get 120. Now simply multiply the numerator, 0.13534 into 32, 4.33088 divided by 120, 0.036. What is this 0.036? P of 5. Probability that 5 houses will catch fire. That is 0.036. That's it. This is the first problem on Poisson distribution. Now see the second problem. It is given that 3% of electric bulbs manufactured by a company are defective. So the data given, 3% of the electric bulbs, that means every 100, out of every 100 bulbs manufactured, 3 bulbs are defective. 3% are defective. Using the Poisson distribution, specifically given in the problem itself, that we have to apply Poisson. Find the probability that a sample of 100 bulbs, n is equal to 100, will contain A, no defective, and B, exactly 1 defective. So first of all, we'll put the data in a notational form. P is equal to probability of defective bulb. P is equal to probability of defective bulb, 3%, 3 by 100, 0.03. N is equal to total number of bulbs, 100. M is equal to NP. N into P. So 100 into 0.03 is 3. So again we got a whole number, M is equal to 3. Since P is very small and Q is very large, we apply Poisson distribution law, according to which P of R is equal to e to the power of minus m into m to the power of r by r factorial. See, in other words, P of R is equal to e to the power of minus 3 m. M we got 3. So e to the power of minus m means e to the power of minus 3 into 3 to the power of r divided by r factorial. This is the formula. Now we have to attempt the questions. The first question, what is the probability that no bulb is defective? chances or probability no bulb is defective. That means R is equal to 0. Now we substitute P of 0 is equal to e to the power of minus 3 into 3 to the power of 0. R is 0 divided by 0 factorial. Now e to the power of minus 3. If you refer the table again, because it's a whole number, so the small table you refer. Below that small table, e to the power of minus 3 is 0.04979. 0.04979 e to the power of 3 to the power of 0. Anything raised to the power of 0 will be 1. And 0 factorial always equals to 1. Right? So e to the power of minus 3 into 1 divided by 1. You will get 0.04979. This is the table value of e to the power of minus 3. Therefore, probability that no bulb is defective is 0.04979. Or if we round it off, the figure will be 0.05. That's all. So one question we have completed. What is the probability that no bulb is defective? Now secondly, what is the probability that one bulb is defective? That is R is equal to 1. Now substitute the value of R as 1. P of 1 is equal to e to the power of minus 3 into 3 to the power of 1. Because 3 to the power of R, here R value is 1. So 3 to the power of 1 by 1 factorial. So e to the power of minus 3, already we got the value 0.04979 into 3 to the power of 1 is 3. 1 factorial always equals to 1 mathematically. So if you solve, you will get 0.14937. So the probability that exactly one bulb is defective is 0.14937. That is nothing but 0.15, rounded off to 0.15. This is the probability that one bulb is defective, and this is the probability that no bulb is defective. That's all. So two problems we have completed. Now I am coming to the third problem. Problem number 3. In a town, 10 accidents took place in a span of 50 days. In a particular town, 10 accidents took place in a period of 50 days. Assuming that the number of accidents follow Poisson distribution directly given in the problem itself, find the probability that there will be 3 or more accidents in a day. What is the probability that 3 or more? 3 or more means 3, 4, 5, 6, 7, 8, up to infinity. Limit is not given. Any number of accidents may take place. 3 or more. That's what we have to find out. Now, here in this problem, the average accident per day is given. 10 accidents took place in a span of 50 days. So what is the average accident per day? So 10 divided by 50. So 10 divided by 50, 1 by 5, 0.2. So 0.2 is the average accident per day. Average accident per day. 10 accidents took place in a period of 50 days. So 0.2. So n is equal to 0.2. The previous problems P and N was given. But in this problem directly average is given. Average is 0.2. Since the number of accidents follow Poisson distribution, P of R is e to the power of minus m into m to the power of r by r factorial. So P of R e to the power of minus 0.2 into 0.2 to the power of r divided by r factorial. Now the question is, what is the probability that there will be 3 or more accidents on a particular day? 3 or more means r is greater than or equal to 3. 3 or greater than equal to 3, right? So P of R greater than equal to 3 is equal to P of 3 plus P of 4 plus P of 5 plus P of 6 plus P of 7, etc. There is no limit. Any number of accidents may take place. So we cannot find out like this. P of 3, 4, 5, 6, 7, 8, 9, 10. Up to how many P's we can calculate? We cannot apply this method. So alternative formula. P of R greater than or equal to 3 is equal to 1 minus. We are starting the probability from 3. So before 3, the probabilities are 0, 1, 2. So before 3, before P of 3, we have P of 0, P of 1 and P of 2. So how to calculate? 1 minus P of 0 plus P of 1 plus P of 2. Because we are starting from 3 here, so below 3 it is 2. So 0, 1, 2, 3 probabilities we require, and we add up the 3 probabilities. So P of 0 is equal to e to the power of minus 0.2 into 0.2 to the power of 0 divided by 0 factorial. Anything raised to the power of 0 will be 1 and 0 factorial is 1. E to the power of minus 0.2. First time we are coming across m value fraction. First 2 problems m value whole number. Whole number we have seen the small table below. Now we are taking the big table, first table. Because m value is in fraction 0.2. So here you can see 0.2 under 0. You will get 0.8187. 0.2 under 0 is 0.8187. So I am taking 0.8187 into 1 divided by 1 is equal to 0.8187. This is P of 0. Now P of 1. P of 1 is equal to e to the power of minus 0.2 into 0.2 to the power of 1 divided by 1 factorial. 1 factorial means again 1, and 0.2 to the power of 1 is 0.2. And e to the power of minus 0.2 we got 0.8187. So multiply 0.16374. This is the value of P1. Now we need the value of P2 is equal to e to the power of minus 0.2 into 0.2 to the power of 2 divided by 2 factorial. E to the power of minus 0.2 is 0.8187. Already we got it from the table. 0.2 square will be 0.04 and 2 square means 2 into 1, 2. So by multiplying this and dividing we'll get 0.016374. So we got P of 0, P of 1, P of 2. All the 3 we got. So P r is greater than equal to 3 is equal to 1 minus P of 0 plus P of 1 plus P of 2. All the values we got it here. So 1 minus 0.8187, this is P of 0, 0.16374, this is P of 1, and 0.016374, this is P of 2. If you add up these 3 values, 0.998814. So 1 minus 0.998814, 0.001186. 001186. So the probability that 3 or more accidents taking place on a particular day is 0.001186. That's all. 3 problems I have completed. Now see the 4th problem. Find the probability that at most 5 defective bolts will be found in a box of 200 bolts. If it is known that 2% of such bolts are to be defective, you may take the distribution as Poisson, specifically given Poisson distribution. Here, what is the probability of defective bolt? 2%. That means in every 100 bolts, 2 bolts are defective. So we can take P is equal to probability of defective bolt 2%, 2 by 100, 0.02. How many bolts are there in the box? 200 bolts are there. In the box, totally 200 bolts. So N is equal to 200. Now M. Because in Poisson distribution, we want the parameter M. And M is equal to N into P. So 200 into 0.02 is 4. M is equal to 4. Now if you refer the table, you will get M is equal to 4 whole number. So e to the power of minus 4 is 0.1832. 0.1832. That is the value. Now P of r is equal to e to the power of minus m into m to the power of r by r factorial. So P of r is equal to e to the power of minus 4 divided by 4 to the power of r divided by r factorial. The question is, what is the probability of at most 5 defective bolts? At most means up to or maximum 5, not more than 5. At most and at least you have to be careful. Previous problem we came across at least, minimum. Now it is given at most maximum. What is the probability that at most 5 defective bolts? So probability of at most 5 defective bolts, that is R is less than or equal to 5, right? So P of R less than equal to 5 is equal to P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5. So totally 6 times we have to calculate the probability. 0, 1, 2, 3, 4, 5. Right? Now P of 0. See here, there are 2 methods of calculating the P of R values. Either individually we can calculate like this every time we apply the formula and calculate the P of 1, P of 2, P of 3 like that. Or if you want in sequence, that means P of 0, then P of 1, then P of 2, then P of 3, then P of 4. In a sequence, if you want to calculate the probability, the shortcut method. The shortcut method is P of 0 is equal to e to the power of minus m. Simply, don't apply the formula. Simply remember P of 0 is equal to e to the power of minus m, and e to the power of minus 4 is equal to 0.01832. In table, if you refer, 0.01832. So directly without applying the formula, remember P of 0 is e to the power of minus m, e to the power of minus 4. We got the value. Now second, P of 1 is equal to P of 0 into m by 1. P of 1 is equal to P of 0 into m by 1. So P of 0, how much we got? 0.01832 into m by 1. M is 4. 4 by 1. You'll get 0.07328. So directly, easily we got it. P of 0, P of 1. Now P of 2 is equal to P of 1 into m by 2. So you want P of 2. So before P of 2 we have P of 1. So P of 1 into m by 2. So P of 1 is 0.07328 into 4 by 2. M is 4. So 4 by 2 will get 0.14656. Now you need P of 3 is equal to P of 2 into m by 3. Here in bracket 3, denominator 3. So P of 2 is 0.14656 into 4 by 3. You get 0.19541. Now P of 4 is equal to P of 3 into m by 4. So 0.19541 into 4 by 4. Same 0.19541. Right? Lastly, P of 5 is equal to P of 4 into m by 5. So 0.19541 into 4 by 5. 0.15633. That's all. So in a sequence, if you want the probabilities, this is the shortcut method. Easily we can calculate. Only 1 or 2 if you want to calculate, you can apply the formula as usual. Now take the total of all the probability from P of 0 to P of 5. The total comes to 0.78531. And we need P of R less than or equal to 5 is equal to P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4 plus P of 5. Add up all 0.78531. Therefore, the probability of at most 5 defective, up to 5 defective is 0.78531. That's it. So in this video, I have completed 4 problems. First 4 problems on Poisson distribution. Inshallah, the next problem will continue in the next video. So if you are satisfied with my lecture, give a like to the video. Share my channel among your friends, among your group, so that more students can watch the video and enhance the knowledge. Give your comments. Subscribe my channel if you have not yet subscribed. And by the super thanks which is given below my video, inshallah we will continue the next problem in the next video.